Hello there. What you're about to watch is my second ever attempt at using the cubic formula. Now, the idea of this video came from the idea that I've never used the cubic formula in my entire life. So I went about recording my first ever attempt, and it was completely raw, uncut, mistakes and all. Unfortunately, the video footage did not save correctly. Okay. So I was unable to use it. I got about 9.5 minutes in of editing and it didn't work out. So what you're about to see is my second ever attempt at using the cubic formula. But I still wanted to try and capture the spirit of the first video. And so what I did was I tried to leave in as much of the technical glitches, the mathematical errors, the oops, I didn't mean to do that. I tried to leave as many of those in as possible, unless it was just distracting from the video, then I may have edited them out. But enjoy. Part of it on the board here, it is listed as my three solutions x1. Oops. Let's go ahead and, okay, there we go. x1, x2, and x3. And notice P and Q have been distilled down to two formulas. Now, those are two pretty big, hefty formulas, okay? But notice the main difference, and really actually the only difference, is this plus and this minus here. So using these formulas shouldn't be too bad. I did generate a random cubic equation because I don't want to give myself any easy breaks on this. So that function was, in fact, I'll write it as x cubed, or sorry, 2x cubed minus 6x squared plus 5x minus 3 equals 0. So let's go ahead. I'm going to go back, and I am going to cut this right here and put it onto the next page. So let's go ahead and paste it. There we go. Okay. There we go. All right. So we have A. We have A is equal to 2. B is equal to -6. C is equal to 5. And D is equal to -3. All right. So again, P and Q differ only by the plus and the minus right before the square root. So this I should be able to just do in one fell swoop. So I've got 2b cubed, so that's 2 times -6 cubed minus 9abc, so that's times 2 times -6 times 5, plus, I'm going to have to write smaller, 27 times 2 squared times -3, okay? And then I'm just going to put plus or minus here, so I'm calculating both of them at the same time. All right, 2b cubed, so that's another 2 times -6 cubed minus 9abc. And actually, here's what I'm going to do. I'm going to make this a little bit easier. I'm not going to write this down yet. I'm going to note that this part right here, this part right here is this part right here, okay? And so let's do the calculations first. I know -6 cubed would be -216 times 2. That would be -432. And we got 9 times 2 is 18 times a -30. So let's make that a plus now. So 9 times 2 is 18 times 5, that'd be 90. 90 times 6 is 540. And then we got 27 times 2 squared, which is 4, times 3. We'll change that to a minus. That's 28. Well, let's just multiply the end result by 3. So 28 times, so 54, 108. 108 times 3. 108 times 3 is 24. Carry the 2. That's 2, and that's, so 324. So minus 324, and then we'll go ahead and we're going to look at adding this up. So 540 minus a 432 would be 108 minus 324, which would be, well, 324 minus 108, that'd be 216, so negative 216. Okay, so, and notice that's squared. Okay, so 216 squared, that would essentially be 6 to the 6th power. Okay, so I'm actually going to pull the calculator out for that one. Let's go ahead and do 216 times 216. It'll end up being positive 46,656. So this green part right in here is 46,656. Now, we're going to work on this part right here. So b squared, that would be 6 squared, so 36. Okay. Minus 3 times 2 times c, which is 5. So we got 3 times 2, that's 6. 6 times 5 is 30. So this overall is 6. And notice there's that cubed there. So 6 cubed is 216. And then times this 4 here. So 216 times 4, that's 24. Carry the 2. That's 4, 6, and 8, 864. So we get minus 864. Let's go ahead and clean a little bit of this up so that I can make room for it. Okay. So we get negative 216 plus or minus. So we got 46,000. Oh. 46,656 minus 864 is 45,792. Square root of 45,792. So let's go ahead and see if we can work this out. So let's go ahead and see if we can work this out just using simplifying radicals. So 45,792, well, I know that's divisible by 4 because 92 is divisible by 4. So we have divide by 4 is 11,448. There's another 4 in there. We got 2,800, sorry, 62. We got another 2. So divided by 2, 1,431. 3 plus 1 is 4, plus 4 is 8, plus 1 is 9. So 1,431 can break down into 9 and 159. And 159, see, that's 9 plus 5 is 6. 14, yikes. And plus 1 is 15. So 159 divided, that's another 3, 53. So 3 and 53. We got a pair of 4s here. We're going to get a pair of 3s from there. So this is equal to negative 216 plus or minus 4 times 3 is 12. Okay. And then we got 3 times 53 times 2. So 3 times 3 times 2 is 318. So square root of 318. Great. So we've got our P and we've got our Q. P would be the plus and Q would be the minus. So let's go ahead. P would be equal to negative 216 plus or minus 12 plus or minus 12 root 318. And, well, I wrote P and Q down. So P comma Q. And then let's go ahead and let's copy that to the next page. So And there we go. Let's move that there. And technical difficulties. There we go. Okay, so what we have here is negative b. So let's remind ourselves a is equal to 2, b was equal to negative 6, c was equal to 5, and d was equal to negative 3. Do I have that right? I do have that right. Awesome. Okay, so we have negative b, so that's a negative of a negative 6 over 3 times 2 minus 1 over 3 times 2 times the cube root of 1/2 times just the positive or the plus of that value. Okay. And then we got minus 1 over 3 times 2 times the cube root of 1/2 times the q value, which is minus 12 root 318. Oh, go ahead and take that out. There we go. All right, well, this right here is positive 6. Positive 6, that's 1. Minus 1 over 6. And I'm actually going to factor out that 1 over 6 because it's common here and here. Okay? So then we get times cube root of, let's see, we got 216. That half of that would be 108 plus 6 root 318. All right. Plus, because when I factored out the negative here, it became a plus. So then, let's go ahead and put a bracket in there then. We got the cube root of negative 108, and I forgot my negative there. Okay, negative 108 minus 6 root 318. Okay, and actually, I don't know why I have these parentheses in here. I just want the bracket. Okay. I think that's good. Okay. Let's go ahead. Let's remind ourselves A is equal to 2, B is equal to negative 6, C is equal to 5, and D is equal to negative 3. So we get a similar situation here, negative of a negative 6 over 3 times 2 plus 1 plus I root 3 over 6a, which would be 6 times 2, times the cube root of 1/2 p, so that'd be 1/2 times the negative 216 plus 12 root 318. Okay. And now we do plus 1 minus I root 3 over 6 times 2 times the cube root of 1/2. Let's see if I can squeeze it in there. Negative 216 minus 12 root 318. And let's go ahead and simplify. Okay, so this once again will just equal 1. I get plus. Now, notice here there is a 12 in the denominator. Now, it differentiates by the negative here and the plus here, so I can't factor the whole thing out, but what I can factor out is a 1 over 12. Maybe that'll look a little nicer. Okay, so we get 1 plus I root 3, okay, times the cube root and this, note this is just the same as what we just calculated on the other page, negative 108 plus 6 root 318, okay, plus, now it's the conjugate, 1 minus I root 3 times the cube root of negative 108 minus 6 root 318. And there we go. Now, really quickly, I'll pause to say, are these simplifiable at all? I honestly have no clue. We could probably go ahead and, I mean, there's probably algebra done if I look at these. But it would look like it would be too hectic. And that's kind of why I chose a problem with random integer coefficients, because I didn't want to be easy on myself. I wanted this to be a challenge, and I wanted it to look scary, and I wanted it to look messy. Now, here we have something very similar to what we're dealing with on the previous page. What are we ultimately looking at that's different? We got a negative here and a plus here, okay? But notice we got the cube root of 1/2 p, the cube root of 1/2 q. We still have the 6a here, the 6a here, and we have the negative b over 3a here. So if we go back, we're effectively going to get this solution, except this will become a minus and this will become a plus. So let's go ahead and I'll really quickly write that out. It'll be 1 plus 1 over 12 bracket 1 minus I root 3 times the cube root of negative 108 plus 6 root 318, okay? And then plus 1 minus I root 3 times the cube root of negative 108 minus 6 root 318. And those would be our solutions. So really quickly, if I go back, now let's try that again. There's that. And then we go back to our first solution. Let's go ahead and screen grab that. That's not the right one. Let's go ahead and paste that in. And there are our 3 solutions. Again, is it simplifiable beyond this? I don't think I can handle that. Thanks for watching this video and entertaining my weird shenanigans. I've gotten a even more fuller appreciation why we just don't do the cube root cubic formula anymore, or have we ever? I never learned about it. Again, this was only my second attempt at it. Things like Newton's method or the rational zero test or things like that. Now, really quickly, I'm going to cut scene here and we're going to check our answers just to make sure, because this was something that I dealt with in the very first iteration of this. Was I thought I was right and I had made a very crucial calculation error at the very beginning and I was wrong. So really quickly, cut to Wolfram Alpha. Okay, so here we go. Our solutions. We have our real solution here. Of course, that's an approximation, and we have our 2 complex solutions. Now, the complex conjugate theorem says if this is a solution, then its conjugate will be a solution. So this could be written as 0.41731 plus or minus 0.72012i, okay? And we can see there's our input. So let's really quickly check back. These were our solutions. I'm going to cut and I'm going to show you what the solution was to this one. And actually, I'm going to start with this one down here. That was our very first solution. This should be real. So, okay, so there's the first answer, the real number solution. And now, remember it was 2.1654, so it rounded off to 4 decimal places, but 3.7. We can see it certainly looks like that's correct. Okay, so let's go ahead and Recall that the other two were 0.41731 plus or minus 0.72012i. I should only need to check one of them because the other one would just be the conjugate. Okay, so cut to that. Okay, there we go. I'm pleased to say that it came out correct. I did face a little bit of trouble with Wolfram Alpha because I had to get used to assuming cube root value is real valued, use the principal root. That was what happened. And so there's a lot of footage of me double checking all my work because I thought I was wrong because I didn't check the right box. Pardon me. If you like this video and you enjoyed this insane attempt at using the cube root formula, go ahead and give the video a like and subscribe. If you would like to see the quartic formula, go ahead and leave a comment in the comment section because I'm just crazy enough to try. Otherwise, thanks for watching.